Thank you again for joining us for today's webinar, EIG's ST40 Compact DIN Rail Energy Meter with Power Quality. Before I introduce our speaker, I'd just like to cover a couple of housekeeping topics. Today's webinar is being recorded. We also invite your comments and questions. If you look at the bottom at the Q&A chat box on your screen, if you have a question for the speaker, please just type it in there and we'll discuss it at the end of the presentation. Today's presenter is Trent Dregseth. He's the Sales Application Engineer with Electro Industries. And at this time, I'm going to hand the floor over to Trent to start today's presentation. Trent, it's all yours.
Thanks, Chris. Hi, everyone. I'm Trent Dregseth, Sales Application Engineer with Electro Industries. Today, I'll be talking about the ST40, which is our small form factor DIN rail mounted energy and power quality meter. The ST40 is one of the smallest form factor meters in the world that does energy and power quality. In addition to the power quality capabilities, this is a 0.2% class revenue accuracy meter. So we have the revenue grade capabilities in here, as well as up to 512 samples per cycle waveform recording for power quality applications. Some key functionalities of the ST40 include revenue accuracy, like I just mentioned. We meet the ANSI C12.20 revenue accuracy standards. The ST40 is a stable revenue grade meter. This means that our 0.2% revenue accuracy capabilities includes the entire range of voltages and currents that can be in the meter. Our meter is 0.2% accurate for current from the low range, where we're looking at 0.5 amps, all the way up to the 5 amp input of the meter. We don't require a full load situation to meet the 0.2% class revenue accuracy. We also have 3 assignable historical logs for load profiling. If you were using this meter for billing, you can have billing software look at one log. You can have an engineering department look at another log recording some power quality information. And you can have a third log for any additional parameters you might need to monitor. This is just a partition, a way to keep information separate, so one department doesn't have to sort through information they don't necessarily need. We also have compensation built into the meter. We can compensate for accuracy loss at the low end of current transformers. We can also compensate for losses from a transformer in a line. So if you have this meter inside your building, it's 100 to 1,000 feet away from the revenue meter. We can calculate the losses of the line between the ST40 and the revenue meter and internally compensate for that loss, so that when you are comparing the ST40 with the revenue grade meter or your billing meter or your utilities meter, the values will match and you don't have to worry about those losses in between. In addition to monitoring energy, we also give you current, voltage, power, including watts, VARs, VA, frequency, and power factor. Revenue features for anti-tampering, the current inputs and the voltage inputs both have seals. So you can put a revenue lock on the meter. If anyone did get in to change the wiring of the meter, they would have to break that seal and they would have to put a new seal on. So if there were any issues, you would be able to see if someone did get in and make a physical change to this meter. We also have a test pulse on the front of the meter for accuracy verifications. When you have the meter in service, you can inject your voltage and current to verify that the meter is still within its 0.2% accuracy anytime down the road that you want to test it. For those of you that use the Itron MV90 billing system, The Shark ST40 uses the same TIM module. If you're familiar with our Shark 200 series panel meter, it uses the same TIM module as that. So this meter is MV90 compatible. Internally, we also have anti-tampering measures where we have a system events log. This records any type of administrative change that was made to the meter, whether someone changed the time, the programming, reset energy or demand values. All of that gets recorded in a system events log, which is not clearable. No matter whether you have full access to the meter, you cannot erase that log. This meter is also a bidirectional meter, meaning if you have a site where you are using utility power as well as generating with wind or solar, this meter will tell you how much energy you've used from the utility as well as how much you fed back to the utility. We also have password protection on the meter. Again, another anti-tampering measure. There's a read password, so someone should have access to retrieve the logs but not make changes to the meter profile. You give them one password or the other. In addition to revenue accuracy, we have power quality, we have harmonics monitoring capabilities, we have waveform capture. We can capture up to 512 samples per cycle on all 6 channels. Your A, B, and C phase voltages and currents will all be captured no matter which leg or phase has the event. We record up to the 40th order of harmonics, both magnitudes and angles. We'll record power factor. And in addition to the waveform capture capabilities, we can set up limits on any parameter the meter can monitor. So total harmonic distortion, individual harmonic magnitudes and angles, power factor, frequency, demand, all of that can be set up as a limit and can alert you if not necessarily you're coming into a power quality event, but if you're reaching your peak demand, you can be alerted ahead of time so that you can make moves to reduce demand. This meter also has communication capabilities. We have a front USB port using micro USB. If you needed to get into the meter locally to retrieve logs, set up a profile, we can do that from the front panel. Also at the bottom of the meter, we have the option of a 10100 base T Ethernet port or an RS-485 serial port. The Ethernet port will talk Modbus. If you choose to use the RS-485 serial port, we have Modbus RTU, Modbus ASCII, or DNP protocols for communication. This meter works with our communicator PQA software. Any of you familiar with our other Shark or Nexus series meters? The ST40 works with the same software you use to connect to those meters as well. We mentioned the small form factor. The ST40 is less than 5 inches wide and a little bit less than 2.5 inches deep by a little more than 4.5 inches tall. So very, very tight spaces. Or if you just have an application where you want the meter installed but don't necessarily want people to see there's a meter, this meter is very easy to hide out of the way. You still have the communication capabilities, but nobody who has access to that room needs to know the meter is in there. It is DIN rail mountable. You do not have to cut any holes in panels. Just as long as you have a rail, or you can simply install a rail that's a couple inches long, mount the meter on that, wire it up, and it is good to go. This meter is also UL listed. Here we have a picture of the unit itself. The top of the meter, you can see the current inputs for our 3 current transformers. The bottom of the meter, we have our 3 voltage inputs, neutral input, as well as a power supply input. This meter does have a separate power supply from the A, B, and C voltage inputs. Again, being a power quality monitor, if you have a facility or a piece of equipment you want to monitor that is known to have severe power quality issues, you don't necessarily want to power a device off of that. So you can bring in emergency power or a UPS power supply into the meter to keep it powered up. And then the meter can monitor the dirty power without being affected operation-wise. Some typical applications for the ST40. Machine level monitoring, especially motors. If you want to keep track of motor health, we can put the ST40 directly on a meter or on a motor. Again, with a small footprint, it can fit in the motor controller panel. You can put it next to the motor. We can monitor voltage. Any sort of voltage unbalance will significantly reduce the life of a motor. We can record that information. We can set up limits. So with the SCADA system, you can be alerted anytime there is voltage imbalance on this motor. So you can start to take the steps to correct those imbalances to improve the life of this motor. We also have the waveform capture capabilities. If there are any noises that are feeding this motor, with the 512 samples per cycle, we can see that, and again, put a filter or some sort of protection on this motor to increase its lifespan. Renewable energy. This is a perfect application for renewable energy because it is bidirectional. Solar panels, those inverters, at night, they stay powered up. So they will pull energy from the grid. This meter will record both the generated power from the solar system, as well as the power consumed from the utility to keep those inverters powered up on cloudy days or nights. Also for wind and solar, if there are any sort of harmonics that are being generated on this, we'll see this. The meter will also give you your VAR generation or consumption if you are requiring VARs to get the motor spinning on the turbines. If you have a solar application where the inverters can generate VARs, this meter will also record VARs being generated from your solar. Hospitals. Anyone who's been to a major hospital has probably seen MRI machines, CAT scan machines. These are very sensitive machines, and if they are fed with distorted waveforms, this can affect the operation of those machines. With surge protection, it's not so much a case now. If anyone has seen the YouTube video from the early 90s, there was a patient in a bed, and without the remote, his bed was moving up and down, folding in on itself. That was because of power quality issues in that hospital controlling that bed. That same type of power quality issue can affect the operation of these MRIs or CAT scan machines, or these highly sensitive devices that require a very clean 60 hertz sine wave for operation. Power quality metering, up to 512 samples per cycle, harmonics up to the 40th order, events that can be recorded. I was saying for voltage, current, we can record waveforms, but for frequency, power factor, harmonics, we can set up alarms. The alarms will record the date and time that event happened, what happened, whether it was a power quality, a low power quality event, a high frequency event. It will tell us how high the frequency went or how low the power factor dropped to, and it will tell us how long that lasted, whether it was 1 second, 10 minutes, a day. All of that gets recorded inside the meter. Commercial submetering applications. If you have a facility with multiple tenants, you can monitor each tenant and bill them for energy use directly. This has been shown. If people have to pay for the energy used, they will be more likely to use less energy. Shut off lights at the end of the day, shut off equipment at the end of the day, only use equipment when it's necessary and not whenever, because now they're actually paying for the operation of that equipment. Also with peak demand charges, you could, in addition to monitoring tenants, allow them to view their peak demand. So if they are getting close to what their peak demand is, they can take moves to lower that peak demand. This is a way that us as utility customers can work with the utility to lower utility demand requirements. Industrial metering, monitoring individual motors is a perfect example. Monitoring assembly machines is a great example. Conveyor systems, those are a series of belts and motors. All of that can cause problems. Using a meter with power quality monitoring capabilities will allow us to view harmonics, waveforms, also to figure out the crest factor or K factor. So we can see if there's bearings on conveyor belts that are starting to go bad or motors that are starting to go bad. We can take preventative measures as opposed to reacting to the piece of equipment failing. All the information from the meter is available from software that you can install on your computer. Because you might be managing multiple facilities and you don't necessarily have access to that, or if you travel quite a bit and you don't always have access to your building network. We also have our energy PQA solution. So in addition to being able to connect directly to the meters, view logs, retrieve information, view real-time readings, we can push power quality and energy information up to the cloud. So now, even if you're sitting in the airport, you can connect Energy PQA on your phone, log in, and view all of your meters information, whether it's energy, power quality. This is compatible on any web browser. So if you're on iPad, Android tablets, Mac OS, Linux, Windows, we work with everything. Here's a couple screens. At this point, I'm not going to go into these screens because I am going to connect to Energy PQA and show you some of the capabilities that you can get out of the cloud software with the Shark ST40. So we have energypqa.com. When you come here, you'll be asked to log in. I have a user account. When When you log in as a user, you'll see your facility or facilities. You have many options on how to view your meters. You can put all of your meters in one facility. If you had multiple facilities around the world, you could put meters in each facility. In this case, we have our one New York office facility, our 1800 Shames Drive location. And we have 6 meters here. Of these 6 meters, we've had 36,000 events. When I click on this facility, I see all of my meters. It gives me a meter type. Because we've just released the ST40, we're going to show you a Shark 200. The reason we're going to show you Shark 200 is because the ST40 is a more compact form factor of the Shark 200. So what we see from the Shark 200 will also be available from the ST40. So if I took a look at our 1700 Shames Drive location, which is our manufacturing facility, we have a dashboard. This first window is the default graph. This is completely user customizable. Whatever you want to see on this graph will show up. You have to set this up once, and every time you log in, it will give you the information you required. So the last time this was set up, we were looking at demand and energy in the interval. We can change this to look at energy in the interval. If you wanted to view your kVAR readings, we could look at that. We can also trend temperature, humidity, or pressure. So if you had a day where you had a really high spike in usage, it might have been a really hot day where cooling was running more. So now I have energy, var hours, quadrants 3 and 4, and temperature. So if these are getting too condensed together, we can always click and drag on an area to zoom in. And if I hover over kilowatt hours, quadrants 1 and 4, it will gray out everything else and bring this energy in the interval value to the front, so I can see exactly what I'm using. You'll also notice over here that we have multiple scales. Our kilowatt hours and kilovar hours are fairly similar, but if you wanted to look at voltage and current, your voltage at 120 amps and your current at 10 amps, instead of having current at the very bottom looking like 0, Energy PQA will create a new trend for that. On Energy PQA, in addition to all the information that the meter gives you, we also have a combination of machine learning and artificial intelligence for energy and demand prediction. So we'll predict a 30-day demand and energy use by day. We use machine learning and artificial intelligence because if we just use machine learning, if you were a facility that was affected by weather, our predictive analysis would not take into account weather. So that's why we also take into account the artificial intelligence piece of this. So here we're predicting our energy use by day. We have from the 16th of November, the solid maroon line is what we used. The dashed maroon line is what we predicted. And the dotted blue line and the dotted black line are the tolerances. So as long as our actual usage falls within these tolerances, our analytic platform is doing its job. This system will use up to 4 years of historical information. So as you have a meter installed, it will become more accurate on the predictions as the software has more historical information to use for analysis. A lot of metering has some capabilities for predictive demand using a rolling demand window. That still only gives you a couple of minutes or maybe 15 minutes to react and shut off some loads before you get your peak demand recording. With Energy PQA, we give you a 30-day demand prediction. So now we're expected to be fairly constant, but if on December 30th, we were expected to have a huge spike, we could take measures starting now to figure out what we can do on December 30th to try and rearrange our manufacturing practice or do something to minimize that peak demand that before it actually happens. Again, down here we have just some default graphs trending voltage, current, frequency, power factor, our demand values, as well as our total harmonic distortion. If you wanted to see any of this information up close, you click on a graph and it will bring up a full screen page of that information. So here we have our C phase, B phase, and A phase current total harmonic distortions. You'll notice that these are very high, typically anywhere from 10 to 30%. If we look here, you can see that it's not just at night when a building is typically shut down. It's during the day that we're running that we have higher harmonics. So this would not be an instance of a low load, falsely high harmonics. This is a piece of equipment that we have on our site that is causing these high harmonics. So what we have to do is narrow down, again, with our equipment level monitoring with the ST40, we can put the ST40 on multiple pieces of equipment to see exactly where these high harmonics are coming from. We can isolate that piece of equipment from everything else with a filter or some sort of protection. So this equipment does not feed back and affect the operation of all of our other devices in this building. Down here we have the power quality, voltage, Sabima curve, as well as any current faults. So in this case, we've got a couple events. Those of you not familiar with the Sabima curve, this isn't a hard and fast rule. This is just a guideline. Anything that happens between this blue and black line here are events that pieces of electronic equipment should be able to continue operation through those events. Anything that happens below this black line are events that probably won't damage your equipment, but they may cause your equipment to shut down. So if you have a server that takes 30 minutes to an hour to start back up again, even though this is not a equipment failure issue, this is a loss of revenue because now you can't operate for the next 30 minutes to an hour while that machine is starting back up again. Anything that happens up here are voltage surges, which could potentially fry the power supplies of pieces of equipment on your system. So you don't necessarily have to look at all the waveforms, but if you do have an event that happens out here, you can drill in now and see what happened and if you need to worry about that affecting your pieces of equipment. With our log viewer software, we can view any of the historical trends from the first page. We can also look at the power quality. And now when I click on this item, there's a sag event. I have waveforms for this event. So when I click here, I can come in and look at the waveforms. So now I saw that this sag lasted several cycles. If I had any pieces of equipment that failed, I'll know that I need to put some sort of voltage protection on those devices. So if this sag ever happens again, that device is protected and I won't lose it or have to replace it. Here we can also see the effect of the current. So again, no matter what parameter was the trigger, the meter will record all 6 channels. So you can see each phase, voltage and current, what went on. We also have a heat map. If you want to see while this is loading, if you wanted to see your typical high energy use, ours in New York is July and August because it's the hottest time. We have HVAC units running almost constantly during the day. So this is showing our highest usage times this year. In the winter, because we're on gas for heating, our usage is significantly lower because now we're not using electric for environmental control. So we can go back to 2019. Again, we can go back 4 years. This energy PQA will keep track of energy information for the last 4 years. And so as long as your meter has logging information from the last 4 years, you can go back to the previous 4 years and look at your energy use throughout the year. We can also compare multiple meters. So if I wanted to compare our 2 buildings at this facility, I can look at the energy for both buildings and see which one has higher usage. Here's a comparison of this year to last year for the main meter, which is my 1700 Shames Drive meter. We've used 25% more energy this year compared to last year. And you'll see here, this is what we've currently used up until today. What's in parentheses? This is what we're predicting we're going to use for this year. So by the end of December, we're predicting we'll be using 239,461 kilowatt hours. These are meter comparisons from this month to last month. So our 1800 Shames Drive building is down, our 1700 Shames Drive building is up. So production has significantly increased over the last month. We've got comparisons per day, weeks, months. All of this information is available for all of your meters. In addition to viewing all the logs, if you don't want to continue to log into Energy PQA, we have a report section where we can create reports and have them emailed to yourself, a group, or multiple people. And now instead of logging into Energy PQA every day to see the readings, we can have a daily report emailed. If that report shows that there's some abnormalities, then we can log into Energy PQA and dig down and view more information. We also have alarm emailing. In addition to getting energy reports by day, week, month, you can set up Energy PQA to send you an alarm. I showed you on the first page the predictive demand analysis. If you don't want to log into Energy PQA to see your predictive demand, you can set up an email alarm. Every time you have a new peak demand predicted, you'll get an email. Again, at the very beginning, when you start using Energy PQA and you don't have a whole lot of historical information, you might start getting quite a few emails for updates as the machine learning and artificial intelligence calibrate to your system. But once you have quite a few months or a year of information, both usage and weather, Energy PQA starts dialing in, and you won't get emails every day. You'll only get emails as a significant event changes the predictive demand. But now again, you can have an email saying, this month, I expect your demand to be this high on this day. So now you have a little more time to start figuring out how you're going to adjust that day to minimize your demand. We can also look at the email history. So if you're supposed to be getting a report and you're not, we can verify that the report was sent. It'll tell the rule name, whether it's a daily, weekly, or monthly report. If you didn't get it, you can resend it, or you can simply download it from here and have the report. Any alerts that happen? Again, if you don't get those alerts, even though Energy PQA said it was sent, you can try resending it. And in this case, we set up a meter to trigger alarms on a regular basis. So if you are getting out of limit alarms for nuisance trips, we can come in and adjust those alarms to make sure you only get an email when an alarm is something you need to worry about and not just a minor interruption that doesn't affect your facility's operations. Okay, so that was the ST40 and the capabilities of the ST40, both as a meter and what you can get out of it from the Energy PQA cloud software.